And now let's discuss the steps or the algorithm to find the inverse of a function. So now to find the inverse of a function, first of all we shall check whether its inverse exists or not. So in the first step we shall check the function for bijectivity, and if it is bijective then it must be invertible, and if it is invertible then we'll move to the next step to find its inverse. And our next step is we shall put f of f inverse of x equal to x, or we can write f of f inverse of x is equal to x. And in the final step, in the formula for f of x, simply replace x by f inverse of x. In the left hand side of the f of f inverse of x is equal to x. And after that simply solve the equation for f inverse of x. And the equation obtained will be the inverse of the function f. And now we shall make use of this theorem to find the inverse of some of the invertible function. And our first question is, consider the invertible function f from R to R given by f of x is equal to 10x plus 7. Find the inverse of f. Now remember from our algorithm for finding the inverse of the function, f of f inverse of x is equal to x, or we can write f of f inverse of x is equal to x. Now f of x is equal to 10x plus 7, and now writing f inverse of x in place of x, the equation will become 10 into f inverse of x plus 7 is equal to x, or we can write 10 into f inverse of x is equal to x minus 7. So that means f inverse of x becomes x minus 7 upon 10. So the inverse of the function f of x is equal to x minus 7 upon 10. Now let's solve one more question. Let function f from natural number to y be a function defined by f of x is equal to 4x plus 3, where y is defined as y belongs to natural number such that y is equal to 4x plus 3 for some value of x which belongs to natural number. Show that f is invertible and find its inverse. Now f will be invertible if f is a bijection, and the function f will be a bijection if it is injective as well as surjective. And now let's first check the function for injectivity, or whether this function is 1 to 1. Now suppose x and y are two numbers from the set of natural numbers, and suppose f of x is equal to f of y, or we can write 4x plus 3 is equal to 4y plus 3. Now crossing 3 from both the sides, so the equation becomes 4x is equal to 4y, and dividing both sides by 4, and that finally becomes x is equal to y. So that means if f of x is equal to f of y, then x is also equal to y. And that is the condition for a function to be an injective function. So that means the given function f from natural number to the set of y is an injective function. So the given function is injective. And now let's check whether this function is surjective or not. Now the given function will be a surjective function if every element y which belongs to the set of y has got a pre-image in the given function. Or we can say for every y which belongs to set y, there is always present an element x in the domain of the given function. But as per the definition of the set y, the set y belongs to natural numbers such that y is equal to 4x plus 3 for some x which belongs to n. So that means for every y there is present an element x from the natural numbers such that y is equal to 4x plus 3. Or we can say every element y has got a pre-image in the domain of the given function. That means the function f from the set of natural number to the set of y is a surjective function. So now the given function is injective as well as surjective. So that means the function f is also a bijective function. And we know it very well that every bijective function is also invertible. So we can find the inverse of the given function. And now we shall follow the steps to find the inverse of given function. And our first step will be f inverse of x is equal to x for all x which belong to the set of y. Or we can also write it as f of f inverse of x is equal to x for all x which belongs to set of y. And also f of x is equal to 4x plus 3. And now we shall write f inverse x in place of x in the given equation. So our equation will become 4 multiplied by f inverse of x plus 3 is equal to x for all x which belongs to set of y. Now taking 3 to the right hand side and dividing by 4. So our inverse function becomes f inverse of x is equal to x minus 3 upon 4 for all x which belong to set of y. So that means the inverse function f from the set y to the set n, which can be written as f inverse of x is equal to x minus 3 upon 4 for all x which belongs to the set of y.